Hello everyone, I'm Dr. Gonzalez, and in order for neurons to communicate with other cells, they need to create an action potential that travels along the axon. So if we zoom in here inside the axon, this is what we're going to see right here. So normally inside your axons, we're going to have, this is essentially the membrane, right? Except as outside there's going to be an extracellular fluid, and inside we're going to have an intracellular fluid. Also, your cell's going to have these proteins in the membrane. Some of these are going to be permeable to sodium, and some of them are going to be permeable to potassium. Now, normally, potassium is said to be in higher concentrations inside the cell membrane, and sodium is going to be outside the cell in higher concentrations. In this case, also, the cell membrane is going to be highly negative on the inside as a resting membrane potential, and positive on the outside or extracellular fluid. Because of these exchange of electrical differences, where the cell is more negative on the inside but more positive on the outside, it causes the cell membrane to be in a resting potential. This resting potential, it's at minus 70 millivolts. In some occasions, sodium channels open, allowing the influx of sodium in the inside of the cell, which causes the cell membrane and the resting potential to reach a little bit of this threshold at minus 55 millivolts. As sodium keeps entering the cell membrane, it keeps making it more positive, and now this is considered a depolarization. And now the cell membrane is considered to be depolarized because now there's more sodium on the inside, making it more positive, and so that reaches approximately plus 40 millivolts. Once the depolarization is finished, now the potassium channels are going to open, and potassium is going to start exiting the cell membrane. In this case, now the voltage changes, and we call this portion the repolarization because of the exchange of potassium to the outside or extracellular fluid. This process of depolarization and repolarization, it's also known as a nerve impulse traveling along the axon. Now, as this keeps happening, eventually, after repolarization, some voltage-gated potassium channels keep opening and potassium keeps coming out of the membrane. So this causes something called a hyperpolarization, hyperrepolarization, which means that now it's going to get even more negative than before. At this point of hyperrepolarization, the cell cannot undergo another nerve impulse because it's said to be in a refractory period. Once that happens, the sodium-potassium pump now starts pumping sodium out and potassium back to the inside of the membrane. And now the process begins all over again. Well, that's it for this video, and thank you for watching.